Let's record it. Okay. If it works, it will be great. Okay, so this guy is purchasing manager for the headquarters of large insurance company chain with central inventory operation. He demanded 6,000 units per year, so their demand, 6,000 per year. The cost of each unit is 100. The carrying cost is $10 per unit per year. The average ordering cost, setup cost, is $30. It takes 5 days, so this is the lead time, right? For an order to arrive. And the demand for 1 week is 100 units. Okay? We are working 250 days a year. Okay. So the first question, what is the EOQ? EOQ, when you are asked what is the EOQ?
Okay, so we know the annual demand is 6,000.
Yeah.
I'm still trying to figure out what the cost and total cost. Is that the? Okay, so the cost, the order is 100 or more. So what? The order cost from one for the only cost from what are you getting? Oh shit, that's my problem. I'm sorry.
Okay, it's given here. Carrying cost is 10, which is carrying, which is all.
I'll be using my problem with my homework. Okay, see, that's why I was like, okay, so
What's carrying? It's all.
yeah. It's only.
Yeah.
Okay, so that's $10.
Yeah, that's the $10. The average ordering cost, which is setup cost, to order, to set up.
That's $100.
That's the $30.
Oh. See, so why did they throw $100 in it? That's what we on me. So we're not using $100 at all?
Let me see.
Give me what I need.
The cost of each unit is $100.
So is that we need?
You know, if the production rate and the cost, you have promotion, you might use it. So we don't use it. Maybe
So they should have left it out. That's what I feel like. You take it out.
Okay.
Additional information, I get confused.
So the EOQ, do the 2BS, you get 189.74 units, right? Which is 188, right? Yeah. Okay, so 188. What's the average inventory? You look there, what for part B, I said the average inventory or is Q over 2, which is 188 divided by 2, which is 94. Okay, this is part B. The average inventory is 94.
Okay. We're in the standard, but if we were in the thing, it would be 95.
Why?
Well, they'll tell them.
Oh, 189. Yeah, 189. Yeah. 95. Yeah.
Oh, yeah, no. You said, I'm still on A, I'm sorry.
You know, I'm talking about this, but in my lab, you know,
It'll even tell you round it up or round it.
Yeah.
Okay.
So in my lab, you round the average inventory to 95. The 190.
And how do you find the average inventory? What do you do?
Divided by 2. Q divided by 2. That's the average.
Oh.
Yeah.
Oh, it's right here.
Yeah, it's the yeah.
Yeah, it's with the home. That's the 189, like 74 divided by 2.
Yeah.
Only 6,000 divided by 189.
To do what? What is the optimal number of orders?
6,000 by 189.
Yeah, the annual, how much you order per year, 6,000, right? How much you order per order? 189? Yeah, divide them. It's
What's that from? That's the same D divided by Q. That's
D divided by Q, yeah?
okay. What is D?
It's the annual demand.
Oh, I'm sorry. Okay. Oh, yeah. Can you tell me the formula for you? I see what the answer is, but.
Oh, we did not do the.
Did it?
Sure. Hmm? No, you keep it. So optimal days between orders, it's how many days per year? 250 days divided by number of orders. That will give you when to order, right? Okay, cost of inventory excluding cost, how many orders times the set up cost plus the average inventory, which is Q over 2 times the holding cost. Like you see B there, which is here. See if I can draw here this, which is we said Q over 2 times H plus the setup cost, right? Which is 10 times average inventory, 31 times 30. Total annual inventory cost. $601,837. You add this to the 600,000. Yeah.
You added that to the 6,000? That's 600,000, so.
That's why you said why we use the 100 there. We use the 100. Yeah, 600, 6,000 times 100 plus this number. Okay. Questions? No questions? Okay, let's move on to the next one. The 26. The 26, the one with the table, which should be
There's a bunch of extra.
oh, we covered chapter 12 before the break, right? I think.
All these
Yeah,
things
which
are
is
working together.
yeah, number 9. Here, number 9. This is number 9, 26. Okay. Which is number 9 on the my lab. Okay. You don't have to do it now. Just take notes, understand it, and then you can do it later. Yeah.
Because if I don't do it here,
Okay. Manufacturing company, their expected demand. Okay. Do the first one, A, which is this one, by yourself. Let's see. I know you will make lots of mistakes. Do it. Yeah, it's all one equation. That's what we use. You see the board? That's what we are using for all the questions. We don't use anything else.
but we don't have to use the table, right? For the EOQ.
I don't know. I asked you to do it.
We just have to use it. We just have to use 750.
I want you to do it, make a mistake, then I will do it, so you will not make the mistake again. Okay. So if I tell you, you will not pay attention.
So we have to, okay, to Anthony this, we have to multiply 700 by 12, right, to get the year.
Exactly, that's most of you for you to do it. Because it's given that the capital D is the annual. So annual means year.
Yeah.
What is given is per month, so you need to multiply the 700 by 12.
And that's gonna be A.
No,
That's gonna be.
That's gonna give us.
That's gonna be D.
that would be the D. And you need to use this equation to find the EOQ.
Okay. So our even. That's the first time out.
So you are given the price listed are shown in table, order cost is 50. So you know what's order cost, right?
So basically, this right here is not giving us, is giving us incomplete information. So we have to do manual calculations to get our annual demand, our ordering cost. and our
They
whole-
are given all. And the price list, order cost is $50. And holding cost is $5. So you put the $50 and the $5, find the answer.
When it's rounded to the whole. When it's rounded to the nearest whole number or.
Yeah, for here we don't round, but for my lab, for the assignment, you round up. Okay, so.
You see, D is 700 times 12. H is 5. S is 50. So based on that, you find the
So,
2 times 84 times 50. So most of you
divided by 5.
on the test of the quiz, they will multiply 2 times 700 times 50 divided by 5, which is wrong. And you will find it's multiple choice, you find the answer and say, oh, it's So make sure you read the question, you read the question twice, you know. It's not just for the test. Imagine that you are the one who order raw material for your business or for somebody, and you order 10,000 items. You buy it, right? You are working in a bakery, right? And you order like milk, you order like 1,000 gallons of milk, and you don't need anything else. You go home. Or you have to work for us for 1 year for free.
Oh, my goodness.
Because at least they should pay for the transportation. Okay, so the answer here is 410. And for the second and third part, you need to find the total cost for each one. So let me go over 1 or 2 of them. I usually, try to know the basics, okay?
What's the next step?
It's the final.
Oh, okay.
Yeah.
I'm gonna say time.
Oh, that's your father.
Can you talk to the other? How many? Yeah,
Oh,
no,
no, we don't have
that's-
time. We have only 4 steps. So we don't have
Exactly,
time.
I'm trying to push it in there.
Yeah.
How much,
Okay.
how many places gonna be on the final?
Similar.
So like 20 something? Okay, that's doable.
14.
That's
49.8.
We gonna come in here and do like that. I'm like, what is that?
Finance.
Very easy.
Very, I think I did 84,000. I'm gonna do that.
Oh, you have one myself?
I did my own 1,680,000.
You did the square root of everything?
Find the square.
Wait, for the EOQ?
Yeah.
Oh, yeah, what's that?
Do you have a financial calculator?
I downloaded. Yeah.
It's better to bring like calculator to a test, not the iPhone.
So another professor, finance professor. had
You know,
this
one time I was in class or test, and I always tell the student, you need not scientific calculator. Don't use, something about you. Don't use an example. Don't use the iPhone calculator.
Yeah, no, that's how calculated stuff.
It's not accurate, yeah, it gives you the wrong answer.
Okay, I have a question, because A was easy, but how do we know which supply? That's the question that got me on the homework.
Oh, I did not do
B.
B and C.
Okay.
B and C, we will do B and C, but I'm not gonna ask you B and C.
Oh, okay. It doesn't have D and C? It did. It caught me up. I got it, but I didn't really
I will
understand.
do B and C in front of you. We will do it, but that will not be on the test, just on the arm, okay?
Okay.
We did not spend long time on this side, but we concentrate on EOQ, holding cost, setup cost, number of orders, the time between orders, that's the basic stuff, okay? So B and C, it asks you which one is better. So what we did, the example we did in the class like a few weeks ago, we used the price. Here, they are not using the price. So you take the first one, which is 1 to 499. Okay, so your EOQ is in the range, right? So use it. Find the total cost.
Percent for.
Okay.
So use your EOQ. Find the total cost. The total cost is similar to this. See, we did that. What's the total cost? It is the holding cost, right? Plus the setup cost. What is the setup cost? The average inventory, right? Which is 14. We said how much the average inventory?
14 by 2.
Yeah, by 2. You always average. Yeah. So times 5. Okay. Plus the holding cost, we said the setup cost, how many times, which is the total inventory, which is 8,400, right? The annual demand divided by your Q. That's what we did for the first one. Okay, let me take you.
Wait.
let me bring the slide for the total cost and put that formula for you, or I should have printed. You need to print these slides, especially this one, the total cost. See, this is the total cost. This is the total cost. Yeah, here.
So
Annual demand.
it's the same thing. Letter Q, it's the same thing.
Yeah, EOQ, the economic or the quantity. So it's like it's like the first two are like what we call it adjectives, right? So we are interested in the quantity. So Q is the quantity. It's the economic or the quantity. So it's Q. So you say EOQ, it's Q. Or Q star. Okay, so the total cost is the holding cost plus the setup cost. So what's the holding cost? Q over 2 times H plus D over Q times H. I will copy this. See if I can copy this. No, I can't. I don't need the numbers, so probably I will take them to somewhere and where? It went somewhere. Let me see where. Let me try to put it here. Not object. Yeah, here. Okay, if you do that for the total cost, for the first one, we said we take the optimal order, which is Q, plug it in, find the total cost for each one. For the second one, I need to go up. I'm still on the first provider or supplier. For the first one, you take the 500, the lowest number, because your optimal quantity is 400, right? As you see, if you order 500, how much your total cost will be? 132. It's this. And then if you order 1,000, how much your total cost will be? Let's see.
So what makes it the best one is the lowest one?
Yeah, the lowest one. So you got 128 here, 920, 128, 920. Yeah, it's the lowest. You just say, oh, this is the lowest one. Okay.
And again, this is we do this for the home of I'm not gonna ask you a question like this. This takes time. You need to do.
It sure does.
Yeah, it takes like you need to do the calculations for 6, 7 times. Usually, usually question is like we only have 1 hour 15 minutes for this. So I put you know, for the point. If you almost 24. Solve the problem. Not 30 minutes for each. It should be 5 to 10 minutes for each, or less than 10 minutes. Okay. Oh, this one. Oh, this one, what you need to do. Okay. Oh, you don't have that? Oh, that's good. If you didn't have it. Are you sure? Why I have it when I do the review? I have it here.
I don't even remember doing that. I did.
You did?
Oh, the Z values, yeah, we did.
Okay. So for that question, you multiply the safety stock is equal to sigma times C. Sigma is given. Okay. Here, the sigma is given 7. Okay. C, you find Z. What is, for your question, if you have access to MIDA, your question, if Z, if it says at 90%, so Z will be 1.28. If I try another questions, let me try this one. Yeah, you can watch the video, but let's say this question, they said, what's the percent? 95%. I click on the table for 95%, so Z is 165, okay? So 165, and how much the standard deviation? It is 6, okay. Do I have calculator here? They should give me calculator. I had calculator yesterday. Anyway, so 165. Let's bring the calculator. 1.65 times 6, right? 9.9. So the safety stock is 10. Okay. And what is the reorder point? Oh, the reorder point Flynn would like to maintain. Flynn, during the past year, the mean lead time for demand was 65. So they need 65. Okay, plus the 10. It's very easy. So you know what's the 65? They gave you, usually they tell you, oh, the daily demand is 10 and the lead time is 7. So the demand during lead time is 10 times 7. But they gave you during the lead time, you need 65 minutes. Okay. So the order point what is when we reach 65, which is enough for a week or whatever, the plus safety stock, which is the 10. So when you hit 75 units, then the storage, you say, oh, we have only 75, so you need to order today. So we will not run out of material next week. But you already have safety stock. Okay? So this is for chapter 12. I think we still have time to go over the. Yeah, we still have lots of time. So the second sheet you have is chapter 16. Chapter 16. So chapter 16, Let me see when the assignment due for chapter 16. It's the 13th, so you still have time. I don't know, probably when we have 1 or 2 chapters to finish. Let me see, is this the first one? Carol? Let me see, where's Carol here? Oh, this is not Carol. Yeah, this one.
You know, all these questions are in the book, the textbook. Yeah. So, this question, Carol has a repeated manufacturing plant producing a trailer hitches in Arlington, Texas. The plant has an average inventory turnover for only 12 times per year. He has therefore determined that he will reduce the component lot size. He has developed the following numbers or data: set up labor cost, annual holding cost, daily production rate, annual demand, desired lot size. Okay, so then he asks you how many minutes of setup time should. Oh, they say he and then they say she, right?
And they haven't worded it too, like where it says annual holding costs on here, it just says it's holding costs year per year. I mean, it's the same thing, but.
Yeah, it's the same. Yeah, I covered that from the book. So how many minutes setup time should she have her plant manager aim for regarding this component? We said, if you go back to the slides again, for the setup time, I go back to chapter 16 slides, and I provided you with what happened here? Yeah, this equation. Yeah, that's what we are going to do. Exactly like what we did in chapter 16. We will find Q star and then find the setup time. Let's see how we do that. Yeah, I will try. This is 16. This should be this one. Okay. So first, we will find. Yeah, daily demand. And the big second annual demand. Okay. So here, QP. Now QP, when you have production rate. In the EOQ, we don't have production rate, we don't involve the E small e, right? So this part is not involved. So this is 0 in the previous example, right? But here, when you have production rate involved, we use this. Okay. So holding cost P, so we find the Q. How much Q was? Oh, okay, it's given. So since it's given, we directly find the setup time. So I square both sides. You don't have to do that, you know, it's already done here. You just take this equation and you plug in the numbers. Here's the equation. they square both sides, so you have Q squared is equal to 2ds divided by H1 minus D over P. And then you take this part cross multiplication and then divide by 2D, you will get that, which is Q squared times the holding cost 1 minus the daily demand, okay, divided by the production rate, okay. And this will give you $2.242. So we are looking, that's what we said, we are looking for time, right? Huh?
Square what we got.
You can do whatever you want. I just need to find S, right? Yeah, this is the S we can put down. Yeah, yeah. And then the setup time costs $2.42, which means the labor cost, it's minutes, right? If you pay $20 per hour, so you divide the 2.2, 2.4 to 20, okay, and then convert it to hour only. Okay.
Let's take it out, all this gonna be that. All this stuff in that little number.
This is 16.1. I think we have two more questions. Yeah, 16.4 is easy. You still need this? Done? Okay. So this is another question. So these guys in Nashville, they produce short runs of custom airwave scanners. The owner has asked you to reduce inventory by introducing Kanban system. After several hours, we came up with this data. So demand during lead time. Oh, we did that recently, right? So we said daily demand is 1,000, lead time is 2 days, right? Safety stock half days, Kanban size is 500. So the demand during lead time is 2,000, which is 2 days time 1,000, right? Okay. The safety stock is 1/2 day, which is 1/2 times 1,000, so 500. So the number of Kanbans is equal to the demand during lead time plus safety stock divided by the size of Kanban. Let me see if I can put this here, which is equal to 2,000 plus 500 divided by 500, which is equal to 5. That's it. Before we did not have this when I was a student. I like it. Yeah. Did you do it correct? On that
Chapter 16 assignment. So this is another manufacturing company. Determine the size. See, here you need to determine the size of Kanban. Here, we already know the size. So in this case, you have this and this and this. You need to determine the 500. So to determine the size we determine the production. Oh, here, they did not give you the production rate because you need the production rate, which is determine our Kanban size. So first we find Q, it's not given. Okay. Which is 50. And then you have the demand during lead time. So you have 16 days times 10. Okay. And the safety stock 4 times 20. So you have 240 divided by the Q. Okay. Here. So this will give us 4.8. So that's the Kanban size is 50 sub-assembly. So we need 5 Kanban. Okay, we are done. Let's see.